let's compute the integral of secant cubed x. Let's approach this like we would any trigonometric integral and break it up so that we have a copy of secant x multiplied by a copy of secant squared x. Now, you would be tempted to continue this like you would any trigonometric integral and replace that secant squared x term by tan squared x plus 1. But if you do that, you will quickly realize that you're not going to go anywhere. So instead, we'll treat this like an integration by parts problem and look at the integral in the form of u dv. And now, I know someone's going to comment this. You can use the reduction formula. I just prefer not to, because I don't do well with memorizing formulas, so this is, to me, easier. So when we look at this as an integration by parts problem, we identify the secant x as u because it's an elementary derivative. So u is secant x, and therefore dx is, as we know, the derivative of secant x is just secant x tan x dx, and dv in this case is secant squared x dx, and this also comes from the elementary integral of tan x, and we know that the derivative of tan x is secant squared x. So now we just plug this into the integration by parts formula in the form uv minus the integral of v du. So plugging everything in, we get secant x tan x minus the integral of tan x times, I just realized there was dx there, that's du. That's tan squared x secant x dx. And now, you might already see it, but there is repetition. So we'll replace this tan squared x term by secant squared x minus 1. So this becomes, keeping that secant x tan x term the same, this becomes, and then we're replacing tan squared x by secant squared x minus 1, so then the whole integral becomes secant cubed x minus secant x dx. And just like I said, there's repetition. We once again run into the integral of secant cubed x. But if we have, on the other side, the integral of secant cubed x dx, then we kind of just treat it like a variable and solve for it. So, distributing the negative and splitting up the integrals, we get the secant x tan x term does not change. We get negative integral of secant cubed x dx plus, because minus and a minus makes a positive, integral of secant x dx. This is all equal to the integral of secant cubed x dx. Moving or isolating my integral of secant cubed x dx terms, I get secant x tan x plus secant x dx on one side, and then I end up with two copies of secant cubed x dx. And now all I have to do is divide by 2, and the integral of secant x dx is something you could either just know, or you could watch a video I made on how to compute the integral of secant x. So the result you get for the integral of secant cubed x dx ends up being secant x tan x plus the natural log of tan x plus secant x all over 2. And of course, we can't forget our arbitrary constant c. And that's it.